In this video, we'll be solving simultaneous linear equations. And what does the word simultaneous mean? Simultaneous means happening at the same time. So, for these two equations we've been given to solve, we are going to be getting solutions that when we substitute them into this equation, it will be true. Into this same equation, it will be true. Just a solution. One result for x, one result for y. So that is what we mean by simultaneous. Noun. So what we are going to do is we are going to rewrite those equations in the solution and we are going to name them. So this is equation 1. The second one is equation 2. Now the next thing we are going to do is we are going to look at the coefficients of the variables and see how we can equate them. What do we mean? Looking at the coefficients of x, this is 2, this is 3, they are not equal. For the coefficients of y, this is -1, this is +1. So just the absolute value, 1 and 1. We can see that the coefficients are equal. So we just start the elimination already. And how do we eliminate? We are going to say, what can we do to this? Is this variable that we are interested in eliminating because the coefficients are equal. So we are going to ask ourselves, between addition and subtraction, what are we going to do to these variables so that they leave this equation? We eliminate them out of this equation. We can see that this is -1, this is +1 as the coefficients. So when we add coefficients carrying opposite signs, we can see we eliminate them. That is, they equate to 0. So saying -1 plus 1 is going to give us 0. So what we are going to do is we are going to add. So we are going to add equation 1 and equation 2. So when we add, we are going to get 2x plus 3x is equal to 5x. Minus 1y plus 1y is going to give us 0. So no need to write it. We've eliminated it. So 8 plus 17, that is going to give us 25. So we can see what we mean by elimination method. Eliminate one of the unknowns. So we are now left that with 5x is equal to 25. And at this stage, we already know what to do. We divide both sides of the equation by 5. And we have that x is equal to 5. Now we've solved for x. We have to solve for y too. Okay, to solve for y, all we do is we choose between these two equations, any one of them. We substitute the value of x into any one of them. So I'm going to do that on this side. So I'm going to pick out equation 1, for example, and I'm going to substitute 5 for x. So we have 2. Instead of having x, we're going to have 5. And then minus y is equal to 8. So we solve. 2 times 5 is 10 minus y is equal to 8. Then we are going to collect like terms. Negative y is left here. 8 is already on this side of the equation. 10 comes over to become minus 10 on this side of the equation. We have that negative y is equal to 8 minus 10, which is minus 2. We divide both sides by minus 1. And we have that y is equal to 2. So we can see that y is equal to 2 and x is equal to 5. Now let's check whether it is true. Now, since I've already used equation 1 to solve this, though I can substitute into equation 1, but I just want to touch this equation too. So as a form of check, so our solution is that x is equal to 5 and y is equal to 2. So as a form of check, what I'm going to do is I'm just going to solve that roughly. So as a check, I'm going to have that, let me pick out equation 2. We have that 3, instead of having x, we're going to impute 5 and plus, instead of having y, we're going to impute 2, and let's see if it will give us 17. And then we have that 15. That's 3 times 5 plus 2 is equal to 17. So it is true, meaning that the solutions to these equations are true. Now for our second example, we have these two equations that we've been given to solve simultaneously. So remember that the first thing we do is we are going to name them. So this I'm going to name equation 1. I'm going to name this equation 2. And then I'm going to look at the coefficients of the variables. Looking at coefficients of x, we can see 2, we can see 3. They are not equal. We can look at the coefficients of y, we can see 5, we can see 2, they are not equal. Now, the next step for us to do, since none of the coefficients of the variables are equal, what we are going to do now is we are going to check what are we going to do to any of the coefficients of the variables to make them equal. So we can do that. We can decide to make the coefficients of the x variable for both equations equal. And how do we do that? We are going to multiply equation 1 by 3. So that 3 times 2x is going to give us 6x. And we're going to multiply equation 2 by 2. So that 2 times 3x is going to give us 6x. So we have 6x, 6x. So we've equated these two variables. Or we can look at these coefficients of y variable. And we are going to multiply this equation by 2 so as to make this 10y. Multiply this equation by 5 so as to make this 10y. So any of those things, that's our choice. But I prefer to go by smaller numbers. So to multiply this by 3 and this by 2. You can go anyway, or even after solving this, you can pause the video, go by eliminating the coefficients of y, and then let's see. Okay, so since I love working with smaller, now we are going to say equation 1 multiplied by 3. So we are going to multiply everything in equation 1 by 3. So let's start. 3 times 2x is 6x. 3 times plus 5y is plus 15y. 3 times 2, that's equal to 6. So, the second equation, that's equation 2, we are going to multiply it by 2. So, we are going to say 2 times 3x, that is 6x. 2 times 2y is 4y. 2 times 25 is 50. So we've succeeded in equating one of the coefficients. That's the coefficients of x. Now what we're going to look at is this is plus 6, this is plus 6. What are we going to do to plus 6 and plus 6 to equate them to 0? That's to eliminate them out of the two equations. Now we are going to subtract. When we say 6 minus 6, it's going to give us 0. So we now say subtract. So we subtract both of the equations. 6 minus 6, that is 0. No need to write it. 15 minus 4, that is 11y. 6 minus 50 is minus 44. Now, this is what we are left, right? Now, we already know what to do. We are going to divide both sides of the equation by 11. And when we do that, we are going to find that y is equal to negative 4. Now, we are going to solve for x since we've solved for y. So, we are going to choose any of the equations and substitute the values of y into it. Now, let me pick out equation 2. When I pick out equation 2, though it's easier to pick out equation 1, but just for variety's sake, I'm going to pick out equation 2 and substitute negative 4 for y. We have that 3 into x plus 2. Instead of y, we're going to have negative 4 there. Is equal to 25. We're going to have that 3x, negative 4 times 2, that is negative 8, is equal to 25. So we are going to collect like terms. 3x is equal to 25 plus 8. And then When we now say 25 plus 8 is equal to 33, we divide both sides of the equation by 3. And then we are going to have that x is equal to 11. We have that x is equal to 11. So we finally solve for x and y. We have that x is equal to 11 and y is equal to -4 as the solutions to the simultaneous equation. Now, as a check, let's check the two and find out. We have that as a form of check, so we're going to check it out. Let's use equation 1 to check it out. So equation 1 says that 2x plus 5y is equal to 2. We're going to substitute these two values for x and y. We have that 2 into 11, that's the value of x, plus 5 into -4. Let's see if it will give us 2. 2 times 11 is 22. Now 5 times -4 is -20, and then plus -20 is just like -20. So 22 minus 20 is equal to 2. Therefore, we can see that the solutions we have are correct.